We'll now look at something called sets. And a set is just a collection of some kind of objects. And these objects are elements. Sets can be any collection of any type of objects. They can be numbers, they could be shapes, they could be people, they could be all kinds of things. So some notation. If we call in set S, in A is an element in S, then we write a symbol like this. However, if B is not in my particular set, then I can draw a line through it to indicate that it is not in there. As an example, I'm going to let Z be the set of integers, and we talked about exactly what integers are in a previous video. So then I can say that 5 is in Z because 5 is an integer. However, square root of 2 is not in Z since square root of 2 is not an integer. There are a couple of different ways that we can describe sets. One of the ways is to just list the numbers between braces. So for instance, 1, 2, 3, 4, 5 would be the set of all numbers between 1 and 5, or the set of all whole numbers between 1 and 5. I could do it as 1, 2, 3, 4, comma, dot, dot, dot. This indicates that we're going to keep going forever. However, this isn't always ideal. What if I want to consider all of the numbers between 0 and 1? I can't exactly show them by listing out all the numbers. However, we do have another notation. They're always still between braces, and we start with saying X, and then we write a vertical bar. This bar means such that. So essentially we're going to say it's all things X such that, and then we're going to give a condition for X. If I say 0 is less than X is less than 1, then these are the set of all numbers between 0 and 1, not including 0 and 1. There are two different ways that we're going to look at to combine these sets. The first is called the union. And if I have sets S and T, their union is denoted by this symbol that kind of looks like a U. And these are the elements that are in set S, or in set T, or in both. The other way that we'll look at combining them is called the intersection. And this is denoted by this symbol right here that kind of looks like the upside down U, the upside down union symbol. These are the elements that are in both S and T. It's what they have in common. So a union is like taking everything from set S and then throwing in everything extra from T. However, the intersection is only what they share and what they have in common. And one quick note before we do a couple of more examples is this symbol right here, a 0 with a line through it. This is known as the empty set. This is the set that doesn't have any elements. It's empty. So let's look at a few examples. Here I have 3 sets, S, T, and V. If I want to find the union, S and T, I'm going to take everything in T, or everything in S, 1, 2, 3, 4, 5, 6, and then I'm going to include T. I've already written down 4 and 6. The only thing new to add would be 8 and 10. If I wanted to do their intersection, it's only the things they share. They both have a 4 and they both have a 6, and that's it. If I wanted to do the intersection of S and V, so I'm looking at the set S and the set V and want to know what they share, what elements are in both. And we can look and see that they have nothing in common, so their intersection would be the empty set. Very much related to this is the idea of intervals. And intervals are certain sets of numbers that we use a lot. They are all sets of numbers between two things. So as an example, a lot of times we write a comma b in parentheses, and this is all the numbers that are bigger than x and bigger than a and less than b. Sometimes we write them with brackets, and these are going to be all the numbers greater than or equal to a and less than or equal to b. So essentially, parentheses means exclude. It means do not include the endpoints. And brackets mean include. It means the endpoints are included in our set. So we've already said that parentheses a and b mean a less than x less than b. And we can also graph these. So here's a and here's b. We would use parentheses on each of these numbers and then shade in the middle. If we use square brackets, this means include, so a less than or equal to x less than or equal to b. And when we graph these, we use square braces on a and b and shade in the middle. And we can do combinations of these as well. We could have a parenthesis a comma b with a square bracket. This would mean don't include a but include b. When we graph them, a would have a parenthesis and b would have a bracket, and we could shade in the middle. Similarly, a comma b with parentheses. This would be include a but not b, and shade in the middle. Sometimes we might want to include all the numbers bigger than a, so we would write a infinity, and this would be all the numbers strictly bigger than a. We would put a parenthesis at a and then shade to the right. You could also use a square bracket, something like negative infinity comma b with a square bracket. This would be all the numbers less than or equal to b, and we would use a square bracket at b. And it's important to note whenever we write these as an interval, which is the first way I wrote them, parentheses mean don't include and square brackets mean include. However, infinity should always have a parenthesis. It's technically not a number, so we don't actually include the number infinity. Instead, it's an idea. Let's look at a few concrete examples. Negative 3 comma 4. So these are all the numbers that are greater than 3 and less than or equal to 4. If I were to actually graph this, here's negative 3, minus 2, minus 1, 0. 1, 2, 3, 4 would have a square bracket, and we would shade in the middle. Similarly, we could have something like 1/2 3. In this case, here's 0, 1, 2, 3. Square bracket at 3 and square bracket at 1/2 and shade in the middle. A couple more examples. Minus 1 comma infinity. Here's 0, here's minus 1, parenthesis there, and shade all the way. Shading the arrow indicates that we are actually continuing on. Since intervals are technically sets, I can take their intersection and union. So in this case, I want the intersection, what they have in common. A lot of times when doing this, it's easiest to start with graphing each of them individually. So the first one says between 1 and 4. The next one, I'm going to let my segments here match the line above it. I would want between 3 and 5. So the actual final answer should see, since this is the intersection, where they overlap. Starting at 3 and ending at 4. So this would be the interval, or square bracket 3 comma 4 parenthesis. For our last one, I want to look at the union, and I went ahead and drew these two intervals. So for the union, I want to take everything in the first and everything in the second. We don't technically include 1. For the first, we go all the way over to 4. And then, although we don't include 4 in the first one, since it has a parenthesis here, we do include it in the second one. So we're going to continue including all the way up to 5. So this would be the interval parenthesis 1 comma 5 square bracket.